Hello friends and welcome to our lecture on operation research. Today we'll be doing the most interesting video. That is how to do big M method using calculator. Well, big M method is a method in linear programming and it requires to solve variables, that is x1, x2, x3, but there's an additional variable M, and that and the fraction parts of it sometimes creates a problem with the calculation. Stay with the video. I'll show you a very interesting method of eliminating that problem altogether. Fine, so let's begin. Now, when do you use big M method? You use it when you have problems that have artificial variables, and artificial variables usually kind of come in the constraints when you have inequalities of the type equal to or greater than equal to. Now, for this, we'll be taking the window or glass problem. This problem is a very popular problem taken up from Operation Research, Frederick Hillier. And I have given a solution to this problem in the previous few lectures also, but that was without the big M method. Now, this is specifically with the big M method. And I have made this video because a lot of my viewers made a comment that why don't you make a video on big M method? So here we are. The objective function is 3x1 plus 5x2. We have to maximize it. The constraints are x1 less than equal to 4, x2 less than equal to 12, and 3x1 plus 2x2 equal to 18. So because we have equal to 18, we will have to use the big M method. So we will have to introduce an artificial variable first, and then we can use big M method to solve it. So that is the way we do it. We introduce the artificial variable a5. So first of all, in the constraints, as you can see, we introduce slack s3 for the constraint 1, that is x1 less than equal to 4. We introduce a slack variable s3. For the next constraint, we introduce a slack variable s4. And for the last constraint, we introduce the artificial variable a5. And of course, the objective function now modifies to 3x1 plus 5x2 minus ma5. Now I'll explain you why it is minus ma5. Because we will have to solve the entire simplex tableau in such a method so that a5 goes to 0 and z goes to the maxima. Till a5, where a5 is a positive variable, till it does not go to 0, we will never achieve the maxima. So that's the entire idea. So what do we do here? We remodify it, that is we rewrite the last constraint and then we replace it in the objective function, and then we get the objective function in terms of m, x1 and x2. Now that becomes convenient because you have eliminated a5 from the objective function. So that's your objective function once again rearranged. Now we assume a very big value for m. That's the trick. Okay, you have to assume a value for m which is big enough so that it is far more greater than whatever is the value of z that you think you might be getting. And that's very simple. Looking at the structure of the problem, you can guess, okay, this is going to be roughly the value of z. Okay, you can always look at the constraints and put the maximum value of the constraints, breaking a few constraints here and there, and judge what's going to be the value of z. Okay, so replacing 10,000 in it, that's the equation you get. Z minus 30,000 3x1 minus 20,000 5x2 is equal to minus 180,000. Now on this slide, we have the simplex tableau. I'll explain the simplex tableau briefly here, how it has been prepared. So on the top row, you have the variables. So z, remember one thing, in your objective function, it starts with z minus something x1, something x2. So z is also a variable. So z, x1, x2, s3, s4 and a5. We all know that these are the variables. And RHS means the right hand side of each and every equation. Now the first row is that of the objective function, and it is followed by the coefficients of the variables. So the coefficient of z for the first equation, that is the objective function, is 1 itself. And for x1 is minus 30,003. For x2, it's minus 20,005. For S3, S4 and A5, it's 0, 0 and 0. And of course, the RHS is 180,000. Now for the equation, that is the first constraint, if written in terms of x1 plus S3 equal to 4. So what do you have now? X1 will have a will have a coefficient of 1, and then under the S3 also you have the entry of 1, and the RHS is of course 4. Similar goes for equation number, that is the constraint number 2, which has S4, and the constraint number 3, which has A5. So I have my on-screen calculator, and it will be taking up a little bit of space. But I guess you guys would be able to understand. But that's for clarity. Now the beauty of this on-screen calculator is it demonstrates how do you do the calculation using a Casio calculator. Now, of course, what's going to happen is, which is the entering basic variable? Of course, the entering basic variable is going to be x1. Why? Because it is got the highest ratio, that is the highest coefficient, negative coefficient. Okay. Now, which is the leaving basic variable? Of course, that's going to be nothing but S3. S3 is going to be the leaving basic variable. The reason being, if you take the RHS and divide it by the coefficient of x1 for the row of x3, it's 4. Now for S4, it is 12 by 0, so that makes it infinity. And for A5, it makes it 18 by 3, so that makes it 6. So the least of the ratio is of course 4. So S3 would be the leaving basic variable. Now we have to do row operations in such a way so that we eliminate or we make all the coefficients in column number 1 as 0 except that of S3. Okay, so there we are. I have copied down the table in the previous slide here on the top, and I'll demonstrate the calculations now. Now to eliminate the first entry, that is minus 30,003, what we have to do, and this make this 0, what we have to do is we have to do alpha A plus 30,003 alpha B and click calc. Now put the value of x1, that is minus 30,003, and put the value of 1 here. So there we are. So we get 0. Similarly, now if we have to repeat the calculations, how simple that it gets. Now we again put the value minus 20,000, 5 for the second column, that is the x2 column, and of course 0. So it's 20,005, and I have written it down here. Now for the third calculation, it's going to be, see how quickly it gets done, 0 and 1. That makes it 30,003. And for the fourth one, it is 0 and 0. There we are. So for the last one, let me demonstrate it out. It's minus 180,000, that is 180,000, and of course 4. 59,988. Now I have written it down here. Of course, the calculator is hiding it out. So see, you have got the iteration. The first row has been solved. Similarly, you can solve it for the other rows also. Now let me demonstrate it for row number A5, just for clarity's sake. So press AC to clear the previous calculations. Now this is going to be this row minus 3 into this row, right? Remember here, I have written here x1 because x1 was the entering basic variable and s3 was the leaving basic variable. So x1 automatically takes the position here. So demonstrating the calculation for the last row, this is going to be nothing but alpha a minus 3 alpha b, and click calc and start with your calculation. So it's going to be 3 and it's going to be 1, and here you have 0 now. Similarly, second calculation, it's going to be 2. It's going to be 2. And then you have, no, so that's going to be 2 and 0. Sorry, 2 and 0. And there we are. So the answer is 2. And I have written it down here, 2 here. Now the third is going to be, of course, 0 and 0. So that's going to be 0 and 0. So that's going to be 0, 1. I'm sorry, I missed the number. That is 0 and 1, right? So that's going to be minus 3, and then afterwards 0 and 0, that is 0 and 0. There we have 0 here, then 1 and 0, that is 1 and 0, that is for the A5 column. So that's going to be 1. And then finally, the final calculation, that is going to be 18, okay, and 4. So there you are, 6. So I have demonstrated for the first row. I have demonstrated it for the last row. You can do it similarly for S4. And this is the first iteration. So now you get the first iteration. Now in the first iteration, of course, the ratio, the negative ratio is, the highest negative ratio is only minus 20,005. So that is the column we select, and the row we select is similarly by looking at the ratios. That is the ratio of RHS divided by the coefficients under the selected column, right? Now, of course, the selected row is going to be the last row. I have copied it down, and similar calculations I have done. I'll demonstrate just one calculation. Okay, so let us say we want to make the do row 1 operation and row final operation, right? So it's going to be nothing but alpha a minus 20,005 divided by 2 and b, alpha b, and click calc. There we are. Once we have done that, we can pretty much start with our calculation. So the first entry is going to be 0 and 0. There we are. So that's 0. I have entered it here. The second calculation is minus 20,000 pi, and it's going to be 2. There you see. It's going to be, oh, I have made a mistake here. So this should be plus here. Right. Delete. It should be a plus here. And we are pretty much done. Click calc. This and this. There we have 0. Right. And the third calculation, similarly, it's going to be 30,003 is equal to and minus 3. So that's going to be minus 9 by 2. Entered here. 0. Similarly, you can calculate it out. Now let's do it for A5. So for A5, let's say it's going to be 0. Okay. And it's going to be 1. So you have 20,005 divided by 2. I have entered it here. Now for the final one, that's going to be minus 59,988 is equal to and 6. There we have 27. So that's pretty much I have demonstrated is how you get the iteration, the second iteration. Now similarly, you select the column for the further iteration, then the row, and the third iteration is there. Now the third iteration is at the bottom of the slide. Now that's the final iteration because you do not find any negative entries along the Z. So that's your final answer. So now the answer for Z is, of course, 36. And of course, in the previous one, the entering was x2. As you can see here, it was x2 and the leaving was okay. So there we are. In this, x1 was the entering variable, s3 was the leaving variable. Now, of course, x2 was the entering variable and a5 was the leaving variable. So as you can see here, x2 is at the bottom. And then, of course, in the third iteration, you have s3 as the entering variable and s4 as the leaving variable. So you have x1, s3 and x2. Now, these are the answers. So x1 is going to be x1. So the coefficient of x1 is 1. Of course, since s3 is here, it is a basic variables. Therefore, s4 and s5 are non-basic variables. So they are automatically 0 here. So what we have now, x1 is equal to, all these coefficients automatically need not be considered. x1 is equal to 2, s3 is equal to 2, and x2 is equal to 6. That's the end, guys. That's the way it is done. Wasn't that very simple? Okay, guys, I have demonstrated this, how it is done, and I have taken a lot of problems and tested this method. This method works. Trust me. And it makes things very fast and error-free. So if you like this video, share it with all your friends immediately and do like and subscribe my channel. And do let me know in the comments what else do you want me to demonstrate. Goodbye, friends.